All right, guys, so I'm going to pick up with part 2 of this video. I did example 1, so now I just want to pick up with example 2 and see if we can finish this up. So again, what we want to do is we want to get this set equal to 0 so that we can identify where our critical values are, where they're on the x-axis, and then get a look at this graph so we can figure out how to solve this. So first thing I'm going to do is go ahead and add 48 to both sides. So that gives me 2x to the third minus 3x squared minus 32x plus 48 is greater than or equal to 0. Now, this is factorable. I'm not going to go through all the steps of factoring. Again, you can check out another video for that, just for the sake of time. But when you do factor this, you wind up with x squared minus 16 times 2x minus 3. Now, yes, I can factor this into the difference of squares. It doesn't really make a difference. Again, all I'm trying to do is find out where the zeros are. The question is not to factor completely, it's just to find the zeros. So if I set these equal to 0 and solve, I get x squared is equal to 16 square root. So I get x is equal to plus or minus 4. So I have two solutions there. And then if I set this one equal to 0, I get x is equal to 3/2. So now on my graph, I have -4, then I have +4, and then I have 3/2, which is between 1 and 2. So now we're going to go ahead and get a picture, graph this. So again, I'm not going to graph it 100% accurately in the sense of every single point. I just want to get the general shape. It's the key values where it crosses the x-axis. Those are the values that are critical, because from there it's going to determine whether I'm above the x-axis or below it. So the graph is going to look something like this. Again, it's just a rough sketch. So what we want to do is figure out what we actually want. Well, we want the point where the graph is greater than or equal to 0, which means it's above the x-axis or on the x-axis. Now I say on the x-axis because we have the equal sign here too. So it's either going to be above or on the x-axis. Well, where does that happen? Visually, you can see it's here, and then you can see it's here. So we need to describe those two intervals. We need to say what they are. Well, we can do a number line chart here. So we have -4. Some students don't like to do this. I think it helps to really see what's going on with the graph and the solutions. So from -infinity, of course over here is -infinity, that's positive. So from -infinity up to 4, the graph is below, that's negative. From -4 all the way to 3/2, the graph is above. And then from 3/2 all the way to 4, the graph is below. And then from 4 on, the graph is above. So we want this. We want when the graph is above, which means it's this interval and then this interval. And that's all we have to do now is just write what that interval is. So we're going from, now remember this is a equals to, so we're going to need to put a closed circle, which would bracket, in essence what I'm talking about. We need a bracket for interval notation. So this is going to go from -4 to 3/2 bracket, union, and then bracket all the way to infinity. Again, we want where it's greater than or equal to 0, so where it's touching the x-axis or above. And right here would be our solution for that. All right, so let's take a look at the next example here. So we have this one, 2x squared minus 5x is greater than or equal to 1. So of course I'm going to go ahead and subtract the 1 here. Get 2x squared minus 5x minus 1 is greater than or equal to 0. So now we want to find out where it's crossing the x-axis. And I think what you'll realize is this is not factorable. We cannot factor this quadratic, which basically means we're going to need to do the quadratic formula. Now, if you want to first, get a sketch of the graph, if you have a graphing utility, just to make sure it does cross, because if it doesn't cross, doing the quadratic formula is just going to find imaginary roots, which is not really going to help you. So it does cross the x-axis, but unfortunately they are not rational values. They're going to be irrational, so we need the quadratic formula. Now, just for the sake of time, I'm going to go ahead and just give us what the roots are, the simplified version. When you do the quadratic formula, it's 5 plus or minus the square root of 33 over 4. Now, I have videos on using the quadratic formula. You can always go back to take a look at that if you do have any questions. Well, where is that? Where is that exactly? Again, we can just do a quick sketch. I don't have to key those values in to get the decimal equivalent, but you're going to be over on the left side and you're going to be over on the right side. So I'm just going to pick two values. And again, these are not accurate in terms of the values, what this will be in terms of your decimal value. Because again, I'm just trying to get a picture. But I know that this one right here will be 5 minus the square root of 33 over 4. I know that's going to be that value because it's the minus, and then this one is going to be the positive value. So 5 plus the square root of 33 over 4. So I mean, you can estimate these values if you want. I mean, the square root of 36 is 6, so this number is going to be a little less than 6 but greater than 5, which makes the numerator negative, which then of course makes the whole thing negative, so it's going to be in this side, and the same thing here. So again, it's just to figure out an approximation. So now the graph is going to open up. Remember, we talked about that. This value, the leading coefficient, is positive, so the graph is going to open up. And I'm just going to stress, this is not an accurate graph of where it crosses. It's accurate in the sense of it's on the left side of the y-axis, on the right side, and then of course it opens up. That's all we really need to figure out what this solution is. So if we do a number line chart here, we know that we have 5 minus the square root of 33 over 4 and 5 plus the square root of 33 over 4. And we are looking for, change the color here, we want greater than or equal to 0. So we want on the x-axis or above. So that's going to be here, and that's going to be here. So we just need to describe those intervals. Remember, that's negative infinity, that's positive infinity. So we want where it's above, which from negative infinity to this root, it's above. And then from here to here, between the two roots, it's negative. And then it's positive from that root on. So we want these values, which are going to be these two intervals. Now, it's going to look weird when you write the interval because we have this expression from the quadratic formula, so it's not going to be that neat, but it's okay. So we're going from negative infinity all the way to 5 minus the square root of 33 over 4 with a bracket, union, bracket, 5 plus the square root of 33 over 4, comma, infinity, and parenthesis. So that is the actual solution for this inequality. All right, so let's go ahead and take a look at some special cases here. So I'm going to just go ahead and do these, kind of go through the graph and why it is a special case. So if you were to look at this right here, you would see that it doesn't cross. If you were to graph it, it does not cross the x-axis. It looks something roughly like this. Well, we want to know when is the graph greater than 0. So we want to know when is the graph above the x-axis. Well, this graph is above the x-axis everywhere. The entire graph is above the x-axis, the entire function. So that means that the solutions are going to be all reals. It goes from negative infinity to infinity. This will all solutions. The whole graph is above 0. Looking at this second case right here, x squared plus 2x plus 1, this actually factors to x plus 1 times x plus 1, which is a double root, which means that it actually touches at negative 1. So the graph comes down, touches at negative 1, and then shoots back up again. And we want to know where is this less than or equal to 0. So the first instinct for students is to say, oh, nowhere. It's nowhere is it less than 0. But we want to know when is it less than or equal to 0. So remember what I said, this touches at -1. So the only answer that's going to satisfy this inequality is when x is equal to -1. Because when x is equal to -1, it is actually less than or equal to 0. That's what the value is. So again, we want less than or equal to 0, which means is it below or does it touch the x-axis? And it only touches the x-axis at x equals -1. So that is the solution for that one. All right, looking at the third one. So x plus 3x plus 5 is less than 0. Again, if you were to graph this, it's going to look something like this here. And we want to know where is it less than 0. I think by now you can tell this graph is never below the x-axis. So this would actually be no solution. That is the actual answer, is no solution. And then this fourth one actually factors to x minus 2 times x minus 2. So we have that double root again. So it actually touches there at 2. And then the graph comes down here, hits it at 2, and then shoots back up. All right, well, what do we want to know? We want to know when is it greater than 0. Notice I don't have the equal sign there. If I had the equal sign here and said greater than or equal to 0, it would be all reals. It would be from -infinity to infinity, but I don't have that. I just want to know where it's greater than 0. Well, it's greater than 0 everywhere except for when x is equal to 2. So we have to basically exclude that value. We need everything but x is equal to 2, because at x is equal to 2, it is equal to 0. So we just have to write that in interval notation. So we're going from -infinity all the way up to 2, but not including 2, and then picking back up at 2 all the way to infinity. So this is how you can exclude just a value or some value. So we just want to exclude 2 from there. All right, well, hopefully this helps with you with solving polynomial inequalities. The next video I'm going to do is solving inequalities that have rational expressions.